on, let's see, our next presenter is Flynn. Ready?
Yes, Flynn is here. Let's see, we're going to bring Flynn.
Flynn.
Hello.
So good to see you.
Actually, I think it's more fair to say that Michele is your main presenter, and I'm just here to heckle or add color commentary or something like that.
We also had to.
Like heckling.
Yeah, hi, Michele. We also had to make sure you were here because I think you've been in every single Kube Crash, so we couldn't break your streak. You're our lucky, I
feel like there's been one or two Kube crashes before I got involved, but maybe not. We should go back and check one of these days.
Yeah, I'd be surprised. But okay, either way, it's so great to have you again. And
it's great to be here.
Yeah, and introduce the new face to Kube Crash, please.
Yeah, so I was kind of amused that we showed up right after the one where the wow, I can't talk. I was amused to see that we were going on right after the panel in which people were talking about being so excited about OpenTelemetry because we're here to talk about OpenTelemetry. Michele Mancioppi here is the head of product at Dash0. Dash0. Actually, Michele, why don't you tell us what Dash0 does? Because it seems pretty cool.
We do OpenTelemetry native observability as a SaaS platform. The distinguishing feature is that we try to make it really easy to use and get value out of it.
Which we at Linkerd really like, because we like working with outfits that are supposed to be operationally simple. Very cool. I'm Flynn. I'm a technical evangelist at Buoyant for Linkerd. So I kind of spend my life preaching the whole operational simplicity thing. And we are going to go in right now to talking a bit about what OpenTelemetry is, why you should care. We have a demo of Linkerd and Dash0 working together to provide OpenTelemetry and help out with observability. We're, in the interest of time, we have it already running, and we're not going to show you how to set it up in this particular thing, but never fear, we do have the GitHub repo that we will point you to so you can go and set it up and try all of this on your own and then let us know what works and what does not work. So, Michele, over to you.
Yeah, without any further ado, I think we might go a little light on why should you care, because the panel did a pretty good job about imposing.
Thanks, panel.
There's also a poll in the. I tried first time I used this platform to create a poll about whether right now you have a system in production that you care about. And if the answer is some form of yes, then that means you probably do need observability. So if you feel like putting it,
and so far
was useful.
So far, I'm seeing 78.6% yes. Sorry, 80% yes. So for 80% of you, this talk will hopefully be relevant. And the other 20, remember it for when you do have systems in production that you care deeply about.
Exactly.
Or even when you have systems not in production that you care deeply about and you're trying to figure out what's going on, because observability will help with that.
Yeah, recently I had the most unconventional system I care deeply about in production, and that was the Minecraft server of my family, with my kids being profoundly displeased about the SLOs and hacking me so hard that I went super duper pro on that. And if you're interested, you can find it online. I have published it recently.
Yeah, I'm looking forward to the blog post of that one.
So let's talk about Linkerd and Dash0 together. So as I said, we're going to go light on what is observability because it was pretty well covered. I will spend a few more words about what is OpenTelemetry, because there is usually a lot of interesting questions around what it is and what it is not. Then we are going to talk about how OpenTelemetry and Linkerd go really well in hand together, thanks to the work of Flynn and his colleagues, among other things.
Well, my colleagues.
That's so true, but okay. And then a quick demo to actually give you a sort of taste of what all the hard work in Linkerd, what can it mean for you? And then I guess questions. If you have questions, please put it in the chat. We love our talks to be as interactive as possible. If you feel like heckling, please go ahead. We love it.
That's what we do.
We usually heckle each other. So if this time we have somebody else doing that, that's also fine.
So this is how you want to try. If you want to try this yourself, and we hope you will, if you scan that QR code, it will take you to that URL at the top, which is the GitHub repo with all of the code that we used to set up the demo that we will show you. If you want to use that code, you must be running Linkerd Edge 25.4.2 or later. It will also work with Buoyant Enterprise Linkerd 2.18 and later. We are going to show this running in a cluster from Civo. It shouldn't really matter what kind of cluster you do. I've also run this in a K3D cluster, for example, but having it in a Civo cluster is kind of nice because that way Michele can poke at it at the same time I am. There are certain tools that you will need to set this up on your own. If you can go to the next slide, please, Michele.
I'm trying. I'm clicking really hard.
Okay, well, while we wait on it to come up, hey, here we go. Those are the tools that you will need to get this set up on your very own Kubernetes cluster. And if you follow along with the README in the repo to do this, it will check to make sure you have all of these, and your life will be wonderful. So that is exactly what we have set up. And now we get to talk about what?
Usually when people go and ask me, hey, what is it that you do exactly? And then I say observability. Then they go like, observe what? And then I explain them with some sort of, I do software that tells you why other software sucks. And that's something that works as an explanation. This is also the kind of meme that pops in my head every time that I need to explain what observability is. The fact that your applications can crash and then doesn't matter, then that's the reason why in the poll there is a question about do you care deeply about them or not. However, when you take 3 people in the room and ask them what observability means, you probably have 5 different definitions of it by the end of the discussion. And this is not something that I would love to go too much in depth, because in reality, as long as your systems run well and you know why when they don't, that's great. That's fine. There is also a certain amount of geographical component to the words that we use to describe what we do. And a little while ago, I actually went and looked on Google for the amount of searches about observability and monitoring. And I was very surprised to find out that with the exception of Equatorial Guinea, that's what you see on the bottom right, monitoring is still mostly the word we use. I think in Equatorial Guinea, there must be something super interesting going on, and I wish one day I would figure out what. But
if anybody lives there, please ask around and let us know.
Yes. For me, it doesn't matter much if you call it monitoring or observability, is that you make sure that your systems work, and when they don't, you figure out pretty fast why. And now we are actually going to talk about one of the best projects out there to give you the effectively raw data to answer questions about whether your system works or not. And that is OpenTelemetry. OpenTelemetry is a lot of things to a lot of people. It is it's effectively like a large amount of projects with a lot of very, very cool people involved about giving you means of extracting telemetry from your applications. And it is also a very large project, the second largest in the CNCF according to some metrics, and it has overtaken Kubernetes and others. And it is very, very cool. Like if you're an unrepenting observability nerd like me, then OpenTelemetry is the best. What it is not, and this is...
Even if you're not an unrepentant observability nerd, OpenTelemetry is pretty cool as you get more used to it.
There is nothing to repent about. Observability is awesome. What OpenTelemetry is not is that despite every single vendor doing today observability or monitoring in some shape or form being involved, there is nothing proprietary to it. Also, the community is it has unspoken rules of conduct about trying not to push particular decisions towards the specific set of limitations of the backends where they would rather wish data went. That's really great. It is driven by most vendors out there with different levels of contribution depending on the size of the vendor in most cases. And it is not a query language. OpenTelemetry is about collecting telemetry, and it's very opinionated in the way that you shape that telemetry. But what you do after you collect it and send it off, that's up to you. However, if you're interested, there is a CNCF tag, or at least there was an observability tag. Now it got recently reorganized into reliability that is actually working on a official observability language, and that is super interesting to follow along. And if you consume observability, go and speak your mind whether what you see developing there is something that sparks joy to you. What also OpenTelemetry is not only it's not a query language, but it's also not a backend. So there are several backends out there that can receive your OpenTelemetry without any modifications, and then they do different things in different ways to it. But there is no official OpenTelemetry backend. And
in particular, I want to jump in there for a moment and point out that this was one of the most confusing things as I started trying to work with OpenTelemetry, was realizing that there was all this stuff talking about OpenTelemetry collectors and all this and that and the other, and it was not initially clear that you actually needed to get your backend running as well. So if you're just getting into this, that's a really good thing to be aware of. Of course, there are backends like -0, shameless plug, that make this part pretty easy. And
there is also a lot of open source and open core, which can be a good choice to start out if you don't want immediately to swipe the credit card with a vendor. So there is actually several ways to go about it. And something else, OpenTelemetry is not boring to work with, and more often than not, it is exciting in the good ways, not the bad ways. Like, for example, when my microserver goes down and everybody gets very excited about it, that's not a good way. The good way is like, oh, that's cool, and it actually works. Now, OpenTelemetry we're talking about does a lot of things, and those things is a way for you to collect signals. That is types of telemetry. And there are several, and today we're focusing specifically on one called distributed tracing. Distributed tracing is a type of telemetry that is the more valuable, the more distributed your system is. And it's effectively creating some sort of breadcrumbs about what happens to the requests getting into your system and propagating across your system. It is the signature, in a sense, signal of OpenTelemetry, because we had before already a lot of open source that was doing, for example, logs and metrics pretty well. You may think of Prometheus and several very successful agents. Distributed tracing, I like to think it was the missing element in the triad of high quality open source out there. And that's where I think OpenTelemetry effectively popped off and gave us a way to do most of our telemetry collection in a way that is not proprietary. Today, you can set up your OpenTelemetry infrastructure and send data to any number of vendors and compare apple to apple which vendor does the best work with it, and it's amazing. It has metrics. The metrics model is mostly similar to Prometheus's and different in some very subtle ways. It has things that are really cool. For example, a built-in notion of unit of measurement, which is my favorite thing, because if you don't know what the unit of measurement is, then your pretty chart is just pixels. It has logs and events, so you can create effectively events in time with attributes, and it's every bit as boring as you make it to be, and that's why it's good. It soon will have officially profiling. So it's already something that is work in progress, and support for it is popping out across the industry. Most of its production profiling is effectively sampling at regular intervals what are the bottlenecks, for example, in CPU usage of your application. which methods you see more often on the stack, and then from there implying which one are the hotspots. It's pretty good. It answers questions at large in terms of what should I optimize first, or why my Lambda function is so damn slow. It's really nice. Real user monitoring, that is one of my very favorite signals, because if your deepest database explodes but nobody cares, then it's fine. But if the user cannot click out on the checkout button, then it's time for pitchforks. And there are pitchforks held by leadership, which are especially pointy. The real user monitoring in OpenTelemetry is admittedly the least successful of the signals so far in terms of implementations and decisions, but it's getting better over time. And it is, if you do not have a solution for monitoring what the users are doing from the web pages that you serve them, go and have a look at the OpenTelemetry browser JavaScript, because it's absolutely 100% better than nothing.
What I'm hearing here is that monitoring is a great place to get involved.
But it's also a great place. You do not need to be an expert to have great value out of OpenTelemetry. Yeah. It's not as simple and polished how, for example, some vendors make it. But with a little bit of solid motivation, you can really go a long way and make a real difference in the quality of the users. Because
and if you do go through and sorry, anybody who does go on and set this up on your own, you will see that we have set this up with distributed tracing and with metrics. We will mostly talk about distributed tracing right this second, but metrics are supported in the demo. So it's another thing you can go take a look at.
Now, at a general perspective, OpenTelemetry is made of a lot of different components and things. A lot of it is just words in a text document. There's specifications, a lot of them. There's proposal for improvement, a lot of them. But there is actual code that you can run, and it's a lot of it. Every single language that you're likely, yes, every single language that you're likely to use in production has an OpenTelemetry SDK to some level of maturity. There is even, and I was really surprised and pleased at the same time to see that there is an SDK in the works for Zig, a very cool language.
Wow.
It's really cool. It's really cool.
Cool.
It's a set of APIs. So, for example, some people out there have implemented subsets of the OpenTelemetry API in very efficient way for specific scenarios. It is some of my favorite things is actually to add the capability of getting telemetry out of software without having to change the software itself. That is what is known as auto-instrumentation. That's what I do for fun, because I have enough traumatic experiences of people failing for several sprints to actually collect one metric more, and I said never again. So I started putting stuff for them. And all your telemetry generated can either go directly to a service, for example, each of your Java applications uploading traces and spans directly to the tool of your choice. But more often than not, you have a proxy in between. And that proxy is the OpenTelemetry collector, and it's amazing. It's effectively a Swiss Army knife for collecting, receiving, transforming, and forwarding telemetry. Some of my favorite things you can do with the OpenTelemetry collector is sending the same data to multiple backends to decide which one you like best. Or you could redact, for example, those pesky credit card numbers that keep making it into your logs in one centralized place. You could also centralize the credentials to be able to push data around in the OpenTelemetry collector and keep the SDKs just talking plain HTTP without authentication, for example, with the collector in the same Kubernetes cluster, to make an example. You can normalize metadata. That's great, because metadata that is not consistent is terrible. You can sample. For example, if you may not want to send 1 million logs an hour, because you like to have occasionally money in the bank account, you may actually sample the amount of logs that you send, find patterns, maybe record the amount of logs as metrics, and then pick which type of signal gives you the best value, the best bang for your bucks. So there is a huge amount of stuff you can do with the OpenTelemetry collector, and at some point I will formalize my idea of maturity. So putting SDKs and applications, great. Mastering the OpenTelemetry collector, then you get into the ninja levels of awesomeness.
Another thing from the perspective of somebody who's started doing this fairly recently is that the OTel collector's configuration is deeply fascinating and powerful and complex, and it will take you a little while to go and sort out exactly how that works.
Flynn,
But
do I hear that you find it exciting?
Exciting is not the word I would use, no. But one very important thing here is the tool that Michele is showing right now will take a configuration and tell you how badly you've screwed it up. And that is a godsend.
Yeah, this was actually the first thing we did at Dash0 because we were wrangling YAML day in and day out, and we were like, this is not great. There must be a better way of doing it. So we donated AutoBean to the community, and tell me if you like it. Back to the regular schedule programming, if I can make my browser behave. Let's go.
Excellent.
Oh, by the way, something that you see on the slide on the right, and it's interesting to mention, is that you collect all this telemetry usually together, right? And you forward it either to different backends or to the same one that can deal with multiple signals at once. Normally, you can live with sending data to multiple backends as long as there is a high quality in the metadata about where your telemetry comes from. The classic example is if through the power of inventiveness, you manage to use 3 different keys to talk about what AWS S3 bucket, the metrics, logs, and traces are talking about, then you are not going to have a great time. And your telemetry is far less useful.
That sounds sadly like the voice of experience there.
Everybody has. Everybody. And then there are these incredible in enterprise projects where you try to convince 40 different people to use the one true standard to do that. Or you can have them send all the data to the collector, and then just one opinion matters. And the way, for example, the Go programming language has told us that the moment that linting something is integrated in the language, you're not going to have holy wars about it in the stand-up meeting. And I like to think that the collector can do that for you for metadata, OpenTelemetry metadata. Serge is asking, does it allow standardizing tracing span based on template in order to ensure consistent trace information across microservices? To some extent, yes. For example, one of the most important things about metadata in OpenTelemetry are semantic conventions.
Actually, I think we talk about that a little bit later, right? So yes. Let's go ahead and move through.
Thank you, Flynn. I was getting excited in the wrong way. So how do we get...
I do want to make sure we have some time for questions at the end, right? So, if we do not answer that question, then
we'll hang around.
Ping us again and we'll make sure. So, OpenTelemetry and Linkerd.
Yes.
So for anybody who has not run across Linkerd, it is a service mesh, which means that its purpose in life is to add security, reliability, and observability to your application, but to do it sort of under the application at the platform level so that you don't have to change your application. Go ahead and advance that one. Linkerd, like most of the meshes, does this by sticking proxies next to each of your application pods. Then the proxies get to mediate and measure all of the application traffic that happens flowing between the pods, which means that it's in a great place to go and collect all of this telemetry and forward it on to the OpenTelemetry collector or directly to the back end. There is a caveat. The caveat is that you must actually tell Linkerd to do this so that it knows how to do that, right? Go ahead. I think there's one more on this. Yeah, you must integrate Linkerd in. If we go on to the next slide, we can see a little bit about how exactly that happens. Oh, wait, I kind of got ahead of myself. What we first see is about metrics as well. One of the other things that happens is that all of the Linkerd components, both the data plane proxies and the components that form the control plane, all expose Prometheus metrics on a particular port. The OpenTelemetry collector, if you tell it to, can just go and scrape all of these Prometheus things and then translate your Prometheus metrics into OTLP, which lets it go and send all of your metrics onward to whatever. There's a question there from Shrirang about Linkerd equals sidecar. Linkerd uses sidecars. It's a lovely existential question about whether we are equivalent to sidecars, but we absolutely use the sidecar architecture.
Besides,
with
the telemetry collector, sorry to interject, does not
go ahead.
send data downstream to your backends in the OTLP format. It, for example, can send data via Prometheus remote write. So if you have, it's effectively in many ways a sort of lingua franca. So you can get data in many formats and get data in many formats. And of course, there are some transformations in there. But largely, if you start replacing your existing observability agents with an OpenTelemetry collector, you seldom regret it.
Yeah, it's been pretty cool actually to watch as we went through the process of integrating all of this stuff and getting it to feed tracing and metrics up to -0. And yeah, it's kind of cool. It's nice to do it that way. All right, onward to how exactly you do this. Okay, so for the moment, we got the builds out of order in this slide, didn't we? Okay, so the Linkerd proxies are able to do all of this stuff. Obviously, I'm allergic to the Jaeger extension. The way you actually configure Linkerd to do OpenTelemetry at the moment is with the increasingly misnamed Jaeger extension, which used to actually use Jaeger format, and then it got converted to OpenCensus, and now it's converted to OpenTelemetry, and it's very silly that it's all called Jaeger.
Although it also spins up a Jaeger. Jaeger is one of
we can.
Yes, it's one of the most commonly used open source tools to actually ingest and visualize trace data. And it's probably the one that you should start with if you find that this presentation is interesting and you would like to get your feet wet.
I'm shocked. I was expecting you to say you should just send it immediately to -0 with the trial plan.
Of course, that is a superior experience, but I'm not going to say that publicly.
So go ahead here just go ahead and build out the next couple. The tricky thing with the Jaeger extension, if you're trying to turn this on with Linkerd, is that if you just install it without saying anything special, you will get a Jaeger running and you will get an OpenTelemetry running, OpenTelemetry collector running, and you probably don't actually want to use those. So instead, if you use the YAML up there, and this is all in the GitHub repo, then it will go through and do absolutely nothing except have the Jaeger extension tell the Linkerd proxies where to send OpenTelemetry. And that's probably the way you really want to do this. One more build on that slide. The Jaeger extension is going away. I'm not going to commit to timelines at the moment, but yeah, it's going to end up where you can just go and set things on the main Linkerd chart. You don't have to mess with the Jaeger extension, and we will all be much, much happier. So, okay, go ahead, and we will let Michele talk about what actually happens. Michele, I am not sure exactly how much time we have left. I think that it might be worth quickly going through this so we can show people how it actually looks with -0, and then we can take some more questions there.
Let's make it pretty quick because distributed tracing is something that can be a bit abstract until it's broken down for you. Imagine two pods talking with one another without anything between, no service mesh, no goodness of Linkerd. They open a TCP socket from one to the other and they exchange an HTTP request. And then Linkerd comes in because you want that sweet MPLS. And you start having proxies in between where your application talks with its nearby friendly neighborhood Linkerd proxy, which talks with its peer, which talks with the application. And you start having these effectively round trips across multiple components. And this is already a significant amount of distribution in the system. And you actually want to see, for example, the latency that your first application sees. Where is it coming from? Naturally, not from Linkerd, but you still may want to see the breakdown. And all of these components can generate trace data for you. At every step of the way between a request getting out and into your other application and a response coming back, you can generate data about what happened. And this data looks a bit like this. So it's actually like this. You're recording this sort of structured logs, which, unlike normal logs, they're not just point in time. They're not like something that happened at one particular event. It starts at one time, like I received an HTTP request, and you record how long it takes you to complete that action. And then you record metadata on it. For example, if it is an HTTP request, you may record which URL you send it to, and which method you asked, and what the response code was, and a bunch of other very useful things that actually describes what happened, and specifically, the most important part is usually what goes wrong. And effectively, as your request traverses all these different components talking one another, you're creating a tree. You're creating a tree of spans. And these spans are linking backwards from one to the other. When you send a request from, for example, the application 1 to the nearby linkerd proxy, application 1 will record a client span. I'm issuing a request. And the linkerd proxy will create a server span that says, I've received a request, and then link the server span back to the client. And this is possible because as your applications interact with one another, they exchange metadata sent along with outgoing requests about which trace it is. And this is known as the trace context. It's effectively a pointer of where are we in the saga of this request, where that saga is a trace. And let's have some more tangible idea of how this works.
One thing, let me point out one thing here, which comes up fairly often when we talk to people about this, is that an important part here is that the applications need to also do traces, do span injection. The proxies working by themselves can't do the whole thing for you here. And so this is a very important thing when people start talking about distributed tracing. We occasionally get questions like, oh, well, what do you mean Linkerd can't do distributed tracing all by itself? Yeah, well, weird thing, Linkerd doesn't actually get to see on the inside of your application. So no, we can't go through and inject that stuff.
Well, Linkerd can create a trace between the applications and the proxies, but if the application on the other side doesn't collaborate, then it's broken traces.
Yeah.
Now, what I'm going to show you is a quick view of how a request in the OpenTelemetry demo application is spreading through the distributed system and what's going on. It starts in the load generator, which is a pretty descriptive name. and then the first request, the load generator is issuing a client request towards an endpoint. And on that endpoint, there is a linkerd proxy for the front-end proxy, which receives a request. It's a request of type server, and then issues a request of type client towards the actual front-end proxy, which in turn issues another request talking with its nearby front-end proxy, because the linkerd proxy will mediate both incoming and outgoing, or in linkerd parlance, inbound and outbound requests. So another trip inside the linkerd proxy with request, and that is forwarded, and then it gets into the front end, which that also has linkerd. So it will go down into the linkerd, into the front end proxy, on the way out through another linkerd proxy, into the cart service, which is when it starts getting interesting. And then within the cart service, you see a lot of stuff going on. And this effectively is a very detailed description of all the distributed interactions that are ongoing. And through this kind of telemetry, you can understand not only where errors originate, but also the impact. Because the moment you see where the request is coming from, then and only then, you can really understand the impact. And remember what I said about real user monitoring is very, very important. The moment your traces begin with the user front end, then you truly understand what it means when your database explodes.
As it will. I believe we are actually out of time at this point. Michele, you want to flip back to the slides, and let's There are a couple of gotchas here. We talked about this one, actually. Your application still needs to create its own spans. Go ahead to the next one. That's a picture about why your application is important. This one is really important. Eventual consistency is the name of the game. As you go through, if you see some request jump in at the moment that it shows up in -0, you will actually see the span get filled out over time as more chunks of it arrive. Not all of the pieces will arrive when you expect them to. That's not a bug. That's just the way this works in our lovely eventually consistent world, especially because I think this is on the next slide. Oh, I guess not. But the other thing that we have had in another version of the presentation, spans don't get sent to the collector until they're finished. So this means that they actually arrive at the collector backwards in time from the way the call stack happened, which can be really confusing when you're trying to watch things in real time. Just, that's a thing to be aware of.
Especially when some of your operations in, for example, the client last way longer than in the server. Then you see the data about the leaves of the trace tree coming in way before the parents. And it can be interesting, especially like long-running jobs like an hour. And then you see the traces where we're still missing the information about where this is coming from.
And the way that looks at -0 is you see this little chunk of a trace that's not connected to anything, so you can't see who called it. And then over time, the upward part of the trace gets filled in, which is cool to watch if you know what's going on. And if you don't, it's really confusing. How about go ahead? We have 2 shameless plug slides. You should check out Buoyant Enterprise for Linkerd. It's really cool. Go to buoyant.io/enterprise Linkerd. And you should also check out -0. It's also really cool. And you'll see that in the demo, actually, if you do that. I think we should go ahead. Oh, yeah, we also have at learn.buoyant.io, we have certification courses. They're pretty cool, too. I think we need to go ahead and drop the video here. I will stick around in the chat for questions. Hopefully, Michele can do the same. You can also always find me at Flynn on basically all of the CNCF Slacks.
Awesome. Thank you both. And
thank you.
Flynn, it wouldn't be a presentation without you running long.